to be brief. I just want to, while it's loaded, I'll just say it. I just wanted to, summarize extremely quickly what we learned and what we hopefully liked from today, but also want to give you just indications of, what you can go and do now. Where do you start now? Go back home and try some of this stuff you've heard about. So I want to be very concrete about what tools you can use to do that, and I'm going to focus on the open source landscape that is available for that. Perfect. Do you want to hit cancel? Okay. So as we learned today, topological methods are really good at revealing global or local to global structure, thanks to the fact that they focus on connectivity properties. And we also learned today that in quite a few apparently very different domains, topology can actually make a difference. And we just had a very nice conversation about whether that difference comes from new insight and understanding or interpretability, or from just sheer performance, or both. So here I just, I have 3 examples. Actually, we saw, well, I'll just point at the fact that there is UMAP and Topo AE on the right in the middle picture, actually 2 things we both heard about today, and I just point you to the relevant papers down there. We also saw that in time series analysis, TDA can make a difference in terms of sheer performance, especially if you're looking at high noise to signal ratios and want to distinguish between regimes. So I just point at the top figures up there, and I just would like you to kind of appreciate that the chaotic and periodic regimes are extremely well discriminated to the right of the diagram in the high noise scenario. And to the left, I just want to, we've discussed it at length, graph classification is another field in which we are seeing very promising developments. So what is, my personal conclusion, this is a very personal talk in a sense, is that this has potential to lead to kind of spring of algorithms in machine learning. Which means we need to kind of understand, or just agree, let's say, on what it means to integrate TDA or topology more broadly into the machine learning workflow, as that is very well established by now and has its own rules and tools to deal with. So our objective is to place topology alongside, as we also discussed just now, the traditional framework in a very effective way. So, we also want to make sure that the ethos of machine learning, or at least, the healthy part of that ethos, is respected. And that means, we want to select various combinations of techniques, both based on insight that we have on the problem, but also in a kind of data-driven way. And this has to be made possible when we want to include topology in particular. We discussed a lot about featureization methods. So I think I'll just skip this in the interest of time. We've understood that there is this need to featureize topology. And we've also just mentioned with Catherine, especially at the very end, the fact that we may not have so many hyperparameters in topological algorithms, so we still have a few, and we need to be able to deal with that. Even choices of featureization methods are sort of, higher order hyperparameters. So all of this must be put in, the typical large-scale cross-validation routines that data analysts use. Topology needs to be part of this and needs to be tuned as a part of the whole. So we approached this problem about a year ago with my team that I'll show in a later slide, and thought, okay, how do we do this in practice? Let's use, there's a wealth of code available, and let's look into that. And of course, we started with the open source stuff. So I do not have time to, to carefully go through this, but a lot of what you see here has been done by or also in collaboration with some of the speakers you heard today. Goody was mentioned at the top. And, I've separated it in this kind of maybe slightly fictional categorization, but it's just to help you maybe get started if you go home and click on these links as the slides will be available. So in particular, let's say what I was mentioning just now perhaps is, in this region here, kind of toolkits. You perhaps as a data scientist would want a high-level approach to data science that includes topology as a tool. Okay, so we looked at what was available, and and said, there's a lot there that's actually sort of ready. For our own applications, we felt that it could do with some wrapping around and some kind of to be put in a single unified framework. So we set out to carry out a project that's now called Joro TDA with our collaborators with the following pillars. And in the red, I just written the way in which we address those requirements. So just going through very quickly, the first is, I've already said, it's very important. Topology needs to integrate very seamlessly, needs to be very easy to combine with what's there. And realistically, you're going, if you really want to address the broad community, you want to use what they use. This led us to choosing Python as a programming language and scikit-learn as the kind of main library or framework for machine learning. Okay, I won't say much about code modularity apart from the fact that it obviously allows you to multiply the number of combinations of different things you can do, and that can be a good thing. We just discussed about what this learning curve may be for topology. So this leads us to the need to have a user-friendly framework that actually feels familiar in a very fundamental way. So we set out to be quite adherent to kind of the canon to the extent that makes sense, of course. Including sort of developer guidelines and such things, and the paradigms of the frameworks we use. Okay, so I'll just skip on the last things, perhaps just point on the data structures. We heard about time series and we heard about graphs, and they're very different data structures. But we want to be able to have a framework that deals with both in a way that's coherent. Okay. So this is why we embarked on this project starting about a year ago. Here's a list of the core team for this project. Let me stress that the input from all of these collaborators have been utterly crucial, and we certainly wouldn't be talking about this today if it weren't for them. And many are part of the audience here, especially the EPFL members. REDS is a laboratory in a school of engineering, not far from here, and they help us with the kind of HPC aspects of all this. There are my colleagues on the right. Some of them I think you've seen already. And we want to thank of course, the funding agency that made this possible, which is the Inno-Swiss funding agency of the Swiss Confederation. And of course, we have many others to credit, many other students who contributed to the code, and it was just a very long list, unfortunately. But you can see it in the commit history. So, okay, just one word on what I, as again, I very personally think the future might be. We still need to, we spoke about performance. Nikki spoke about the witness complex and why we would need to do that. There's still space, I'm sure, for performance-oriented kind of improvements at the very algorithmic level, or even sort of the level of tricks, HPC tricks that actually historically have been shown to make a big difference. One thing that Bastian mentioned, and I reiterate very strongly, is the need for a strong community, the need for us to address the broader data science community very directly. And the Slack channel that Bastian created is a nice place to start. And something that we vaguely, I think we kind of tantalizingly mentioned today was what about topology and deep learning? And I think Fred mentioned the fact that, and probably others too, the fact that topology can help actually understand models and how they learn and what they learn and if they generalize well and so on and so forth. This could be very relevant in the field of deep learning. And in my opinion, and I think maybe it was also mentioned, this is still something that requires not quite maybe a breakthrough, but further improvements on the issue of how do we backpropagate through topology in some sense, at least in the persistent framework. So this is what I am very excited about for the future, and I hope you can all see it very soon. So thank you very much for attending this track. It's been a pleasure to have you here. Thank you.